Hi everybody, your assignment for today/tonight is to watch this video, and it's going to give you a quick introduction to how solving by elimination works. It's our third method of solving systems of equations, and that will mean that we'll be able to launch into more examples, but more teacher help time right when we start on Monday. So how will you get credit for this assignment? You have to take notes on paper. Okay, and you have to show those notes to one of the two teachers. Either we'll collect them or we'll just check them off and give you credit. But you have to take notes on paper. They don't have to be the longest notes in the world, but you're going to have to take notes on paper. Okay. So what we're going to do is we are going to ask the question first, what are we going to allow to do with equations? And then we're going to see two examples from the extra practice and two examples from the digestion day that we can solve using this exciting new method. Okay, so let's take an equation. The whole idea of an equation is that an equation is balanced. Okay, that's an equation. X plus 3 equals 11. Now, am I allowed to add 10 to both sides? Yeah, I am. Interesting. Why? Because 10 equals 10, and that's balanced, right? Now, does it help me to add 10 to both sides? No, not really, because then I get x plus 13 equals 21. So I haven't done what I wanted to do, but I've done something that's allowed. Am I allowed to subtract from both sides? I am. I can subtract 13 from both sides. And this not only, right, because that's also an equation, that's also balanced, and that not only is correct, is a thing I'm allowed to do, it also gives me my solution, okay? So basically, this big idea of an equation in balance, right, if I have two equations, and I add them together, if each one is balanced, then I'm allowed to add them to each other, right? Just like 10 equals 10 and negative 13 equals negative 13, I'm allowed to add whole equations. So where on earth would I use this? Okay, so let's start with yesterday's extra practice, which many of you didn't do. And we had changed that because that was a typo to 12, okay? So some of you did this for your homework. I said you either had to do the bonus homework or the, extra practice homework. And this is a problem that can be solved by substitution, but can also be solved by elimination. So let's just paste that pretty picture in. And let's make sure we understand what that means. The first thing we're going to do is we're always going to want to line up our equations super nicely so that the x's go with the x's and the y's go with the y's, right? We know we're not allowed to, we're not allowed to add things that aren't like terms. But this one is lined up so beautifully. I have x plus y equals 26. I have x minus y equals 12. Isn't that so beautifully lined up? X's over x's, y's over y's, numbers over numbers. Now, what happens if I add these two equations? They are both balanced. Now, something really interesting is going to happen. What's x plus x? X plus x is, yep, hopefully you just yelled it out, 2x. What's y plus negative y? Hopefully you just noticed that y plus negative y is actually 0. And that's why this is such a really, really helpful method. Because now we don't have a y anymore. We have eliminated our y term because y plus negative y is 0. And so now I know that 2x equals the sum of 26 and 12, which is 38. Well, that's an equation I know how to solve. Let's divide both sides by the coefficient of x, and let's get x equals 19. Now, the funny thing about this method, elimination, is that only the first step is elimination. The second step is actually substitution, right? So our big step 3, really, we're going to call it, and I'll have all the steps written out for you on Monday in the note, in the INB page I give you, is sub the value you got back into one of the original equations, right? You've done this before. It doesn't matter. It doesn't matter which one we sub it into, okay? So I can do x plus y equals 26. Well, now I know that 19 plus y equals 26 minus 19 minus 19. Y equals 7. I'm not going to do any checking right now because we don't have a lot of time on this video, but we have solved by addition. Okay, so there's one more example I want to show you. I'm sorry, that's the digestion from yesterday's extra practice. And this is of a case where it isn't lined up beautifully. Now, on Monday, we'll probably only work with ones that are lined up beautifully and ones that have a little bit of monkeying around to do. But I need to make them look right like they were before. So what does that mean? I need to put the x's with the x's and the y's with the y's. So before I'm going to put my equations back in their boxes, I'm actually going to subtract x from both sides of this. And that way I'll have my 3 columns just like I like them. I'll have an x column, I'll have a y column, I'll have an equals, and I'll have a number column. Okay. So my first equation is now negative x plus y equals negative 2. And my second equation is x plus y equals 12. So what makes this work? Okay, by the way, that was step 1, which we will call put the terms in the correct places, right? I had to move that x over. Why does this work? Because I've got a negative x and a positive x. And when I add them together, I'm going to get 0x, okay? So that's our big idea. Need opposites, right? Negative x and x are opposites. Now, step 2 is really simple. Step 2 is add. Okay, so I'm about to do that. Add. And I'm going to get negative x plus x is 0x. So that variable has been eliminated. Y plus y is 2y. Whew, that's good. And negative 2 plus 12 is 10. So now it's I just wrote the wrong number. It's very easy to find y, right? That's equation solving, I know. And step 3 is sub it back in. It doesn't matter which. I'm going to choose x plus y equals 12. X plus 5 equals 12 minus 5 minus 5. X equals 7, right? And so I'm going to write my ordered pair. And then just to check, I want to check it in this original equation here, just to be sure. Y equals x minus 2. Check, right? That's really 4. Y equals x minus 2, right? So BYOP, but 5 equals 7 minus 2. Oh, hey, that works. I'm so happy. Okay, so there were 2 on the digestion day that could have also easily been solved by this. And I'm actually going to suggest that if this feels good to you, you should totally pause before I solve it and see if you can try it on your own, because that's one way that it's going to be really helpful for you. Okay, so here for step 1, I right now have y's on opposite sides of the equal sign. So I'm actually going to have to move my y's. Okay, so I'm going to set it up, and you should feel free to do that thing that I suggested and pause and do it yourself and see if you can do it as well as I can. So what I'm going to do in this first equation is I'm going to minus 2y from both sides. Okay, so my first equation is now, I just want black, x minus 2y equals -1. And note that that's a minus 2y, but we haven't seen one like that yet, but it still works. And this is x plus 2y equals 7. So when I add, my y's are going to be eliminated, even though there was 2 y's here and 2 y's here, because they have opposite signs. Super helpful to us. So now I just need to add, and I get x plus x is 2x, -y plus 2y is 0y. Bye-bye y, you've been eliminated. Ba-da-da-dum. And -1 plus 7 is 6. And so we divide both sides by 2, and we get a value for x. And we can sub that back into our original equation, where that x is 3 plus 2y equals 7, right? So we all know how to solve that. We're such good solvers, right? So now we know that 2y equals 4, y equals, right? We divide both sides by 2, y equals 2. I was rushing there a little bit, not good, Baranowski. And now I've got a solution, and I'm going to want to check that in that original equation that I monkeyed with, because that's the one I'm most worried about having messed up. So I'm going to write x equals 2y minus 1, because anytime I play with something, I could make a careless mistake. You know, I could mess something up. So 3 equals 2 times BYOP, 2, minus 1. 3 equals 4 minus 1. 3 equals 3. OMG, we're so smiley. Okay, so I have just 3 more minutes, and I want to show you just one more quick example. And so this is example number 10 from the digestion day, and it's so nice to do it this method. We're going to paste, and I encourage you to try to do it on your own with pause the video, do it yourself if you're feeling bold. Okay, so this first equation is in great shape. I'm ready to write it right in. 5x plus y equals 2. We always want the x's and the y's and the numbers in a consistent spot. Here I've got to move my y over. So I'm going to minus y, and get x minus y equals 4. Okay, now I am ready for step 2, which is add. I'm going to add, and I'm going to get, oh my gosh, it's not 2 of something. I have 6x equals 6, but you know what? I still know how to solve this equation. And now I have x equals 1, and I can sub, right? That's step 3. I can sub. So now I have 5x plus y equals 2. 5 times 1, BYOP, plus y equals 2. 5 plus y equals 2, minus 5, and I get y equals -3. So now I'm going to write this as a coordinate pair, and I am going to check, okay, because I monkeyed with that second equation, x equals 4 plus y, and I want to make sure that it satisfies that original equation before I monkeyed with it. So x is 1, and it equals 4 plus -3. And you know what? 1 does equal 1. And so we are happy. And so on Monday in class, I'll take questions, we'll do more examples, and you'll be able to practice. Shabbat Shalom.